Hi everyone, this is Purnima Mahalingam. In this video lecture series, next we are going to discuss about 3-point starter and direct online starter. So in 3-point starter, we have already discussed about uh, protective methods of HS protective method. So today now we are going to discuss about next protection. It is known as next protecting device. It is known as so function protection or OR overload release. So here we can see the functions. So this is the OR device or as a another protecting device OR is known as a overload release is provided in series with the armature circuit. This R is a small electromagnet. In case the armature current exceeds the present value due to the overload, OR become more strong and attracts the movement ions M pivoted at the end. Here we can see pivoted at the ends. As the soft ion M is attracted to terminals A and B of a no volt release HC. Here we can see the HC short circuit. In this manner, HC get demagnetized and starts our H is pulled back to the off position by the spiral spring. This motor is thus automatically disconnected from the mains in case of overload. The motor current is at which the overload operate can be adjusted manually by varying the distance between the electromagnetic and movable soft ion AM. So limitations of 3-point starter. Here the speed suppose the normal and the field current must be reduced. At certain values of speed current, therefore increases the motor speed, the electromagnetic pulse of the holding coil may become less than the spring coils. We know that the flux is inversely proportional to flux and speed. Now, the flux is indirectly proportional to the speed. Here, the flux is indirectly proportional to speed, or the speed is also indirectly proportional to flux. Here, the 1-point flux is smaller, the field current is reduced, and F in series with HC magnets. Okay, this is all about 3-point startup. Here now we are going to discuss about direct online startup. Okay, now we can see what is direct online startup. Here, the direct online starter, the induction motor is connected directly across its three-phase supply. The direct online starter consists of two switches, namely start and stop. It is also circuit breaker or MCB over the relay contact of the protecting of the motor. Here we can see the direct online starter. We have a no switch, the normal operator, non open, start, normal, closed stop. Here we can NO is open, NC is closed. Here normal open and normal close. We have an MCB and circuit breakers. Here we have a fuse and we have a thermal overload relay and magnetizing coil. Here the contact to keep coil energizing. Here the contactors, and here we have a squirrel cage induction motor. In the protecting from overload relay and contactors from the protecting of the motors. Okay. This is the direct online starter. Here the advantages of direct online starter is it is inexpensive, gives more complex starting torque at the beginning, and designing, operating, and controlling its starter is easy. And its disadvantages is starting current is very high. This starter causes an important dip in the voltage. The lifespan of the magnet might be reduced. These are the major disadvantages of direct online starter. Here we have an star delta starter. This star delta is based on the fact that the star connected 57.75% of the total voltage appear across the coil. The starter windings are connected in the starter at the starting instant. After the motor attain rated speed, the change over the switch connected to them. Here we can see the direct online starter. We have an TPDM TPBT switches and run datas, and we have three-phase supply, and we have a star connected stator windings. Okay, star delta, the star connection, delta connections. So the advantage is it's suitable for high inertia and simple, cheap and effective and efficient and limited to application where high starting torque is required. So not suitable for line voltage exceeds 3000 volts. These are the some of the advantages and disadvantages. And finally, this auto transformer we can see in next class. Thank you so much.